Hello, welcome to BMOX. In the last video, we solved Leetcode problem 7, that is reverse integer. We tried to solve the problem like how we would solve it in an interview. We went through steps like asking clarifying questions, providing brute force solution, writing pseudocode, writing modular code, and providing time and space complexities. However, we ran into some issues because of capitalization. So these are things that we should have caught, right, during the dry run. In interviews, we want to write as close to production ready code as possible. So we should not run into these errors. And the best way of detecting these errors is doing a dry run. So let's practice that art again. We will continue to improve little by little each video. Today, we will solve Leetcode problem 64, that is minimum path sum. So continuing with the solution for the minimum path sum, let's read the problem statement once. It is given that we have a m cross n grid which is filled with non-negative numbers, and we have to find a path from the top left to the bottom right cell in such a way that it maximizes the sum of all the numbers along the path. And we are given that we can only move either down or right at any given point in time. So at any given cell we should either move down or right. Now this question actually does not give us a lot of chance to ask clarifying questions. And the reason is that Leetcode uh, tries to clarify all our assumptions right away because it wants us to be quick at problem solving. And that is good. But in interviews, the examiner or the interviewer might be looking for certain different sets of skills. And one of them might be, are we able are we able to remove the ambiguity from a given problem by asking clarifying questions, or are we able to narrow down the scope of an ambiguous question to actually capture what the interviewer is asking. So for this particular statement, for this particular question, we also want to make the interviewer know that we have understood the solution. So if the manner in which an interviewer might ask this question is, you have a grid, m crossing grid, which is filled with numbers, and you have to traverse that grid from the topmost left cell to the bottommost right cell, and you can only move from a given cell, you can only move either to the right or to the bottom, and you have to find the minimum sum when you reach the bottommost right cell. So whichever path you choose, you have to pick a path, and whichever path you choose, the sum along that path should be the minimum when you compare it with any other path that you could have taken. So it's your prerogative to ask, okay, can we encounter negative numbers in this? Can any path contain a negative number? And the interviewer might say yes, or the interviewer might say no. Let's assume here that the interviewer has said no. There are no negative numbers. Just like the question, this grid is filled with non-negative numbers. Now, a very good way to tell the interviewer that, okay, I have understood the problem, just check once that I am going in the right direction, is to realize that this is a recursive statement. This question is a recursive one, and write the relation. So ms, or the minimum sum at cell x comma y, is the value of the cell at x comma y plus minimum of ms x minus 1 y and ms x y minus 1. So that means that the minimum sum at x comma y will depend on the minimum sum at the cell above it and at the cell to the left of it. And when we have both these values, we will make a decision. So this statement is a fairly good statement to give to the interviewer to make sure that the interviewer knows that you have understood the problem. Now the next step is realizing, okay, this is a recursive statement because the minimum sum at one step is dependent on minimum sum at steps preceding that. And let's see, and whenever you get a statement, a recursive statement, or whenever you get a problem which has recursion in it, the next question that you should go to is, if this has recursion, let's see, does it have is this a contender for dynamic programming? And the way to know whether a particular problem is a contender for dynamic programming is to find out whether there are computations that are being done more than once, or whether there are values which are being computed more than once. So let's check that. So for let's take example 1 as our example. For minimum sum at 2 comma 2, that is the bottom rightmost cell, this value will be 1 plus minimum sum at this, the one directly to above that. If you can see my cursor, I am pointing to 1 comma 2, and the minimum sum at the cell just to the left of it, that is 2 comma 1. Okay, no repetitive calculations as of this point. Let's go one step further. The minimum sum at 2 comma 1 will be dependent on minimum sum at 1 comma 1, that is the cell directly above it, and the minimum sum at 2 comma 0, that is the cell directly to the left of it. Similarly, the minimum sum at 1 comma 2, that is this cell containing 1, will be dependent on the cell above it, 0 comma 2, and the cell to the left of it, 1 comma 1. Now we see that the minimum sum for 2 comma 1 and the minimum sum for 1 comma 2 is dependent on minimum sum for 1 comma 1. If we don't calculate and store the minimum sum for 1 comma 1, we will have to calculate this multiple times. So to avoid that, we need dynamic programming, and this shows us clearly that this is a problem of dynamic programming. And we can present this line of thought to the interviewer so that the interviewer knows that we have thought this out in a foolproof manner. Now, as in any dynamic programming question, this can be done in a top-down manner, and this can be done in a bottom-up approach. Now, the top-down manner is where you start with a solution. Start with one case. For example, here we can have 2 comma 2, and this will be 1 comma 2 and 2 comma 1, and so on and so forth, so that when we reach a base case, and a base case here can be any element that lies in the topmost row or any element which lies in the leftmost column. And why? Because any element which lies at the topmost row, you can't go above it. So if m for ms of topmost row is 0 comma let's say y, you can't go ms of minus 1 y. Similarly, in the leftmost column, you can't go to the left of it. So ms of anything x comma 0, you can't get this value ms of anything that is x comma minus 1. So any element in the topmost row and the leftmost column will qualify for the base case. So this is the top down approach. You start with the bottommost and the rightmost cell, you go towards the topmost and the topmost row and the leftmost column, and along the way you keep caching the result. You store the results that you know that you encountered or that you have computed, and whenever another computation requires that result, you just fetch that. The bottom up approach is, you know, the base case. The base case is the topmost row and the leftmost column. You start from there. you start building your solution from there incrementally, one by one. So you can propose both of these approaches to the interviewer. And let's suppose in our case, the interviewer says that you can go ahead with the bottom up approach. So what we'll do now is we know the approach that we want to take. We know the major blueprint of the solution that we will be attempting to write. So let's write down the pseudocode for that in comments. So solving the problem in a bottom up manner. Now we, as I said, we will be when we solve with the bottom up approach, we start with the base case and incrementally build our solution. In this case, the base case is topmost row, then leftmost column, and then incrementally compute for the rest of the grid. Return the value for the rightmost, bottommost cell. Now, one thing which you can ask the interviewer is, we will be calculating or computing the value, the minimum sum for all the cells. Do we need to create another grid to store the results, or can we use this existing grid to store those minimum sum results? Let's say for now that the interviewer has asked us to store the results in the original grid itself. Let's go ahead. Let's compute for the topmost row. We'll be writing a for loop. Now let's see in the topmost row what's changing is not the row number but the column number, which will go from 0, 1, 2 to the last column. So let's let's name our variables in an appropriate manner. So column 0, column is less than the number of columns, which is grid 0 dot length, and column plus plus. And what we'll do is grid of column grid of column equals grid of column minus 1 plus grid of column. But for 0th column number, this will fail. But we don't need to override the value at 0th column, so we'll make it 1. So this loop will start at first column 0, 1, the first column, and work on the topmost row till the last column. Okay, this makes sense. Now let's pre-compute for the leftmost column. Again, the thing that you see that is changing is the row number, and what's common and constant is the column number. So similar to the piece of code, the for loop that we have above with appropriate naming, let's write this down. For row equals 1, row less than grid dot length, row plus plus, and okay, so there are a lot of mistakes which I did, like not initializing this, uh, and grid of column means nothing because it's a two-dimensional grid. Grid of 0 column, 0th row, 0th row. Similarly here, let me declare this, and grid of, now the row is changing, so row 0 equals grid of row minus 1 0. Okay, for the rest of the grid, let's iterate over it and start from where we left. We will be iterating over the remaining grid, not the topmost row or the leftmost column, but the grid which is left. So we'll start the row with row number 1, not 0, row less than grid dot length row plus plus. And similarly for column, and grid of row column is equal to math dot min of grid of row minus 1 column and grid of row column minus 1. And lastly, we will return grid of okay. So in the last video, the one step which we missed was doing a dry run. So let's do a dry run for this case in this video. So pre-computing for the topmost row, column is equal to 1, grid of 0, 1, that is 0, 1 this with 3 in it, equals grid of 0, 1 that is 3 plus grid of 0, 0 that is 1 that is 4. So here the value will be 4. Then column will increase and it will become 2. So grid of 0, 2 that is this one with 1 in it will be grid of 0, 2 that is 1 plus grid of 0, 1, and this became 4, so this will become 5. So this will become 4 and this will become 5. Now pre-computing for the leftmost column, row equals 1. Okay, so grid of 1 comma 0, which is this one, equals grid of 1 comma 0 that is this one plus grid of 0 comma 0 that is this. So this becomes 2. Similarly, this will become 2 plus 4 that is 6. Now for the rest of the grid, let's continue. So 1 comma 1 will become will become 1 grid of 1 comma 1 plus minimum of 0 comma 1 and 1 comma 0. So that will become 5 plus minimum of 4 or 2. So that will be 2 plus 5, 7. Here it will be 1 plus minimum of 5 or 1 plus minimum of 7. That will be 1 plus 5, 6. Here, moving here, it will be 2 plus 7 or 2 plus 6. This should be 6. 2 plus 6, that is 8. Now final, it will be 1 plus the value at 1 comma 2 or 1 plus the value at 2 comma 1. And this was, if I'm not mistaken, 4, 5, 6. This was 6 and this was 7. So 1 plus either 6 or 1 plus 7. 1 plus 6 is less and the final answer becomes 7. So we have 7 as the answer. Let's do a quick check for the syntax. Column, column and column. Okay. This seems fine. This seems fine. Let's try running this code. Okay, this is working. So the time complexity and the space complexity is one thing that we want to cover. So time complexity, and we have two normal loops here and one nested loop. So let's calculate the time complexities for each loop separately. Now we are iterating for the topmost row. The thing which is changing is the column. So if there are n columns in the grid, this loop will be executed n minus one number of times. And if we convert that into an order of magnitude thing for the time complexity, we will be getting O of n. Similarly, the second loop will iterate on the row, and if there are m rows, this loop will be executed m minus 1 times. So the time complexity will be O of m. Now the time complexity for this nested loop, so it iterates on rows. If there are m rows, it gets triggered or executed for m minus 1 times. Similarly, for every time the first loop gets executed, this gets executed n minus 1 times. So this is m minus 1 into n minus 1, which will be O of mn minus m minus n plus 1. But this is an order of magnitude calculation, and the order of magnitude for m into n will always be more than the order of magnitude of m or n. So we will be removing the linear terms here, and we are left with a quadratic kind of term. If m and n are of the similar order, this becomes O of m square. So again, going ahead with the same logic, O of mn will always be significantly greater than O of m and O of n, and even O of m plus O of n for the purposes of time complexity calculation. Now let's move ahead with the space complexity. So if we were using another grid to store the computed results, the space that we would have taken is m into n, all the number of all the cells, into space taken up by one integer, because every cell will be containing one integer, and one integer, the space taken up by one integer is common, is constant. So let's take that out of complexity calculation, and this will be O of mn. But so let's write that in case of new grid. But here what we have done is we have stored the results in the original grid itself. So we have not used any additional space. Okay, with that being said, let's submit our code. And we see that our code runs and is accepted. So one thing which we actually missed here is we tested our code with two cases, but we did not consider edge cases. Now what can be the edge cases here? The most obvious edge cases which comes to mind and which might come to mind in an interview setting is, what about grids with just one column? Or what about grids with just, okay, this is the grid with just one column. And what about the grids with just one row? Or what about a grid which has just one element? These are the obvious edge cases or test cases that we should be looking at, and we can and we should demonstrate this in an interview setting, unless the interviewer says, okay, that's good, let's move on, because the interviewer might have some other question in their mind. So we, but unless specified otherwise, we should always ask the interviewer, can we test our code with some edge cases, with some test cases. We'll do this with the other questions in future videos. Till then, keep learning and keep improving. Thank you.